Okay, we'll be going over predictions and probability. We'll be using an example from TensorFlow, which is an API framework called Keras that just makes it user-friendly for solving machine learning problems. That's why you see Keras here up at the top. And Keras is a TensorFlow framework that makes defining and using machine learning easy. Sequential, the follow shows that we're going to define a sequence of layers. Refer back to when we talked about them in neural networks and what roles they play in predicting the rules of data and answers. Adding lines of code within the sequential will add more layers into the code. We'll also define the type of layer here, dense, which in this case, yes, it's the dense layer, and these have the most basic types of neurons in them, which is the only type you'll need to know. So units show how many neurons it has inside the layer, and since there's only one defined, there's only one layer. The input shape parameter will define the shape of the data that we'll train our layer on. But how do these layers of neurons learn to match data to labels? So remember what labels are. They're establishing rules that will match rules to data and answers that are fed in. For machine learning, they match data and labels together by actually taking a guess. They would then take the second line of code here, and then this code contains two functions and evaluates the guess. The loss function will evaluate how good or bad that guess was, and then use the optimizer function to take another guess. The next guess would then be evaluated again by the loss function, and then passed over to the optimizer function to make an improved guess. And then this process goes on and on and on, as you can see down here. You can also think of it like a game of hot and cold, where you start by making a guess, and then the system will tell you how far off your guess is, aka the loss. You then make an improved guess based on the system, and it will again tell you if you're either warmer or colder. You keep playing this until you get warmer and warmer to the best possible model. The next two lines are where we define our data. This is just the same numbers you saw earlier, but following that is the learning part, where we tell the program that the x's and the y's fit with each other, and then do the loop from earlier however many times you want, with this epochs that we set to 500. And finally, you can use the program to make refined predictions on the rules that govern these x's and y's. Here we're asking the program to predict the answer x, which in this case we set x to equal to 10. Now, disclaimer, the model will not predict the exact answer, but it will come very close to it. That's because machine learning predicts probability and likelihood. Since it was trained on such a limited amount of data, it can only do these two. Now, the data happen to be linear in this case. However, the computer doesn't assume that every data point will be exactly that, linear. So it spits out the answer, and it thinks that the probability is very high, that the answer is somewhere close to 19. Now, we'll see how this kind of machine learning can be used to give computers vision in the next exercise.